Oh, good morning, evening, afternoon, etc. Hope everyone's having a good Sunday. I've lost all track of the days. I hope everyone had a good Christmas as well. Try out something slightly new layout, starting layout. No holding screen, just straight into the action today. So let some people filter in, and we'll start. I'll go through what we're going to go through in a second. I guess I'll probably poll a few times today. How is the audio? Because I've redone my OBS setup and changed all the mic settings. So interested to know if this is audible, terrible, good, okay, possible, etc. And then yeah, we'll get started in a minute. I'll kind of go through what the plan for today is, what HDR is, why we want it, etc. We'll kind of go through a recap of what we've done. So we've been not streaming, missed out Wednesday for obvious reasons, so I'm just a lot going on as well, so I'm trying to get back into the swing of things myself. Good to see you, Queco. Is the audio alright? I've changed my settings. I have no idea if this is any good. I could just be talking into the void. Sounds good. Okay. Cool. Okay, some positive messages coming in. Okay, so we'll probably start. So I've got a fancy preview of the screen last time, and then ooh, exciting. Okay, back to the standard view. Also have this scene, and then I also have classic me in a circle, and then or me. Oh. How's that? Are we back? I'd forgotten to copy the mic source over to the bottom transition. So I don't know. Maybe we'll start with this one because it's fancy. But if it's not, because I tend to move my hands around a lot, and it really can't cope with that. So we'll see how we get on. So basically, last time we had this. So we've got now we've got a skybox. We've got a whole bunch of barrels that get rendered, not in any efficient way. There's no instance rendering or direct rendering or anything like that. It's literally just thank you for the floppy sandwich. Thank you very much for the Prime subscription. If you do have a Prime subscription and you want to spend it with me, that would be much appreciated, but obviously no need to if you don't want to. So yeah, we've got a skybox, and then we've got a little debug menu, and then we've got some lights that we can kind of move around. So we're kind of getting there now. I have broken down kind of my next set of thoughts into a Trello board, because that seems to be the tool du jour for anyone making a little game. I think there's like 2 or 3 like mechanics things to do, like building blocks to lay. So I want to do HDR today. Hopefully, it's going to take up the full stream and maybe a little bit more. Would like to do HDR. And then, let me see if I can, I don't know if I'm logged into it still. Where do we get to? I want to do, then I want to do the asset pipeline, because as we'll see today, building this and loading this scene is incredibly slow. Async is not that efficient, and I've not even built a release build of it. So I want to do HDR today. Next time I want to build up the asset pipeline. So we'll define our own custom file format that is super fast and kind of friendly for the game. And then we'll build a tool that will just take in like a manifest file. Wow, Emery gifted 20 memberships on YouTube. Thank you very much. What a lovely gesture. Thank you. I guess everyone, welcome to the memberships. Very kind of you. Happy New Year to you too. Yeah, so then we're going to build out an asset pipeline. So that'll be, we'll put all of our assets in one directory. We'll create like a manifest file, and then we'll have like we'll write a little standalone tool which will process all that into a binary blob that we can understand and super fast for us to read. And then we'll plumb all that into CMake, so we can just configure CMake to update the assets, and that'll make things a lot smoother and a lot easier to work with. We'll also use that as an opportunity to kind of fix some of the fudging I've done around texture loading, like 3 channels, 4 channels. We'll kind of smooth all that over at the same time. And then after that, I'm going to put in a physics engine, just because I think we're going to need it. So we'll spend a whole stream, probably maybe 2, seeing how it goes on, integrating some sort of physics engine, and then we can, I don't know, maybe push the barrels around and load up a little scene or something. And then and then frustum culling I want to do as well. Then everything graphics I've kind of deprioritized after that. So anti-aliasing, SSA, AO, they're all kind of like nice to haves, but they won't really get us anywhere, whereas I think all the others are kind of important for us to do. And then after that, I've basically got a bunch of mechanics, the actual gameplay for some puzzles that I want to start integrating. So I think we'll basically then just start churning through those, and then we'll see where we are. We'll see where we got on. Is the camera blue? No, it's just, unfortunately, it's my lighting has like a bluish, I guess it's pink, but it's a bluish hue over here. So I think when you kind of cut everything out, it just looks like I've sort of shifted the color temperature down a lot. I'm playing around with it. We'll see how it goes. Is there any way to contact me directly about a project? Yeah, there's. If you go on the YouTube channel, there's under like this the channel about. There's a contact email address that is anyone's free to contact me on. So feel free to go and find that. Quick Twitch break, but that's fine. We'll start chatting about what we're going to go. Okay, so the problem we've got is that we're currently rendering in, I guess, low LDR, like low dynamic range. So if I just keep adding lights, we can see here that all the colors, I mean, this is only red, so this is 100. Can you see how all the colors clip out and then basically cap out at max red? And that's because our rendering, what you output to the screen, every RGB value has to be in the range of 0 to 255. Okay, that's kind of like how the hardware works. It's how everything expects it to work. So you only have 256 kind of values for each RGB component, and you can't really go. There's nothing above 255, right? So what happens is if you try and this is adding lots and lots of lights together, and what's happening is they're all basically capping out. They're all effectively capping out at 255, like maximum. So what that means is we kind of lose all the details. So if I go a bit closer, you can't really see any of the texture detail anymore in this one, because it's just basically completely maxed out with all the lights. So what we want to do is do what's called high dynamic range or high HDR rendering, where we create a frame buffer, so an area of memory we render to, which allows for more than 256 values. It will use a float, like a 16-bit float, which gives you a huge amount more like fidelity, and then that way you can kind of accumulate the lights above this sort of max like 255. There's some problems with that though. In the fact that eventually you still have to output those accumulated values in the range of 0 to 255. So if you just render to a floating point frame buffer, and then map that back to a standard byte buffer like we've got here, then you'll kind of undo everything you've done. So then we have to do a thing called tone mapping, which is a way of kind of mapping like a high range of values back to the low range, but maybe like preserving the highlights or preserving the shadows, and you kind of, it won't be a linear mapping, it'll actually be along a graph, so you can kind of get different you'll actually get a lot of that, the detail still through. I'm waffling a bit, we'll get to it when we get there. The first thing to do is to basically set up the pipeline that we've got so far, the rendering pipeline, so we can render to an additional frame buffer and then render that to the main buffer. Breathe. Right. So what does that actually mean? So sorry, there's a little bit of exposition to start with today because we've got quite a lot to get through. So that I guess like a frame buffer is just an area, is just an object that represents an area of memory in your graphics card that represents, you know, the frame, so pixel values, okay? By default, we've not really had to worry about any of these yet, because when we create the window and do all the standard setup, we get a default frame buffer. So everything we've rendered to has so far rendered to the default frame buffer. In fact, technically there's two because there's a back buffer, but whatever. Like, don't have to worry about that. Basically, everything we've rendered has gone to this magical buffer, this magical area of graphics card memory that has automatically been allocated for us. But what we can do is OpenGL allows us to create our own frame buffer, so we can actually allocate our own area of memory in the graphics card, render to that, and then we can basically, once we've rendered to that, we can then read this whole screen as if it were a texture, and then we can pass that to like another shader, and then we can read from that and sample from it and modify it. So yeah, that's what we're going to do. We're basically going to end up with something that looks exactly the same here, but with additional steps. So we're going to render the whole scene to, rather than the default frame buffer, our own frame buffer, and then copy that over to the default one. That way we can start like adding additional functionality and messing around with things. So I guess kind of the plan is we might write a little post-processing shader, which kind of demonstrates this, and then we'll do the HDR stuff, and then we need to do gamma correction, which I'll get onto when we get there because I've already talked a lot. And then we need to do like sRGB textures, and there's a whole host of stuff to get through today. So let me just check I'm on a clean slate. So we've this is our standard code. We've done, set up our camera, set up our cube map. We've handled all of our events, and we do all our rendering. So it's nothing too stressful so far. So if you're just joining us for the first time, welcome. Glad you're here. We've basically just set up a very simple C++ and OpenGL, well, a C++ abstraction over OpenGL, and we just kind of pulled it all together to just draw some things. So we can load meshes, we can do lights, that kind of thing. And at the bottom, somewhere around here, is our render function, and then this just handles setting up like buffers for our camera values, setting up buffers for our lights, setting up the skybox, and then basically looping through the scene and drawing everything individually. And so it's kind of it at the moment. There's lots of room for optimizations, there's lots of room for extra bits, but at the moment it's pretty reasonably standard OpenGL code. Yes, evening, Hand. Glad you're here. Had a good Christmas. Hope you did too. People saying there's no contact information on the YouTube account page. There definitely is, because people email me like almost every day, and that's not a criticism. I'm absolutely fine. I will respond to pretty much to most people. Apparently, you have to click more. It's not something I know because I know what my email address is, so I very rarely have to go to YouTube to find it. But it's definitely there. Okay, right, so let's start off with trying to render to a frame buffer. Again, there's some stuff we're going to have to set up here. There's going to be a lot of boilerplate to set up here. Let's start writing. So I've spoken a lot. Let's write some code. So once, no, so I've not worked on this in a week, so to bear with me while I kind of refresh my memory on everything that's gone on. Class frame buffer. We're going to want a OpenGL, and then we're going to want one whole OpenGL. We want and then the auto release, whatever that is, auto release. And then we're also going to want includes int, so we can start creating our frame buffer object. So the frame buffer, to start with, it's just going to be using all the stuff we've already got. So I'm not worried about HDR and floating point frame buffers and all that. I'm just going to give it a size. We're going to allocate some memory for that. We're going to attach a depth buffer to it, and then we're going to try and render to it. So yeah, frame buffer is different from buffer. Frame buffer is a specific concept within OpenGL which stores a frame data, whereas a buffer is kind of because there's different types of buffers. You've got uniform buffer and shader storage buffers. They're more like arbitrary data that I might want to write to and pass between the shader stages, whereas a frame buffer is literally the thing that represents like what the data that you want to render to. So this is a continuation of the Crate game. It's not really a game yet, but we're slowly getting there. As I was saying earlier, I think there's like 3 or 4 more things I think we need to implement, and then we can actually start looking at making a game. I've got a few ideas. I've been mulling it over Christmas. It could be terrible, but I think it'll be fun to implement at the very least. Like, I think there's some fun mechanics to program, regardless of whether they're fun to play or not. GL uint. I guess for anyone joining us on Twitch or YouTube, I'm dual streaming to both, and I have a chat window which shows me the both. So if it doesn't look like I'm responding to a question you can see, it's probably because it's from the other service. Okay, and then we're gonna want auto GL uint. Nope, what am I doing? Sorry. Native handle. Oh, I've not typed anything in a week. GL uint. Okay. And then I think we're going to want auto. You need to bind the thing to render to. So basically, because OpenGL is a state machine, whether you like it or not, it's probably a state machine. So we're going to bind the frame buffer to say, okay, all draw operations now go to this, and then at the end we can unbind it. I think that's kind of enough to get going, because a bunch of the chuff is going to end up in the constructor. So let's start with this. So let's bring in our frame buffer object, namespace game. Let's go Inc 19G and then bring that across, stick that in here, and then frame buffer, and then down. B Control V down frame buffer. I guess this is one of the advantages of using trading return types, is that everything always lines up nicely. Okay, right, so now we can start filling in the blanks. Let's do return handle, and then I think it's, I'm just checking the docs as I go along. I think I want handle 0 u. Oh, hang on. OpenGL. Right, back to our list of Welsh town names as we add some more functions. So we got OpenGL. So OpenGL create frame buffers proc, and FLG create frame buffers, and then I think it's going to be GL delete frame buffers proc. GL delete frame buffers. I think that's what we want. That should get us going. Is there a specific reason I keep using auto and casting HDR joints? I'm not casting anything. This is just as in C++11, they introduced something called trailing return type, which just allows you to specify the return type at the end. And I've never used this before, so I was very unopinionated on it. So I wanted to use this project as an excuse to try it out on a sort of medium-sized bit of code. So that's what I've been doing so far. I don't hate it. I might have to start the lights because people are thinking I've got this purple hue because my wall lights, which you can't see, are casting a purplish hue on me. This needs to be a lambda, right, if I remember correctly, because I think GL delete buffers takes 2 arguments. Let's do that, this, and then, no, that's wrong. It needs to be that, then auto, that's const auto buffer. It doesn't need to be a reference, does it? Because it's just an integral type. And then we can do GL delete frame buffers 1 address of buffer. I think that's what we've been doing. Have I spelled handle wrong? Let's build this and see what we get to. CMake, and then we're going to do a frame buffer.cpp and check that's right. Okay, let's oh, is that not? Okay, fine. Let's build this but not run it. Apparently the audio's gone. Is that true for anyone else? Let me know. Someone said the audio's gone. This is a different, slightly new setup, so be prepared to debug this live with me. Audio works. Cool. Okay. What have I done wrong? GL not a member of the GL delete frame buffer. Have I already forgotten to save a file? Is that what's going on? Yep. Nailed it. It's not a stream unless I forget to save a file. We're not I'm not that fussed on efficiency at the moment. There's several things. I've got notes on where there are improvements for efficiency, and we might do a couple of streams in the future where we optimize things, but for now, we're not really rendering a lot. It doesn't really matter. Okay, let's go back here. Let's do, just wanna, okay, so I'm gonna need to create, so when you create a frame buffer, you actually create the textures, like the OpenGL textures, which represent the thing you want to render to, and then you kind of attach those to the frame buffer. So we will need to manually create a color texture and a depth texture. You can have multiple target rendering and all that sort of stuff. We're not doing that at the moment. So I need to have a think about how this is going to work. I think we're going to need to, I think the frame buffer will own the textures, objects, and then it can pull out the OpenGL handles from that and do the OpenGL gubbins it needs to do. You've seen people make a case against exceptions, saying never to use exceptions, understand if the code running on a vendor system, but I don't understand why people are saying for desktop dev. I don't understand either. I think they're partly misunderstood, and I think partly just kind of have a bad, well actually I think large part is they've actually misunderstood. I go through, this comes up all the time, so I'll do my mini rant on this, and then I'll do it again on the next stream. I don't think the language makes sense without exceptions. To not use exceptions means to define an arbitrary subset of the language, which I don't particularly agree with, because I think it then makes it hard to interact with other people's code or to bring new people onto the project or all that kind of thing. My view on, I think you kind of got to take a step back and not think about exceptions and error codes and all that, and think about like what is an error? An error for me is you're in a function and you are unable to fulfill the for valid preconditions, i.e. you've been given valid input, you are unable to meet the post conditions of the function, i.e. you cannot do the thing that the function said it was going to do. So that is an error, right? So you have to communicate back, and obviously you can return like a Boolean, you can return an error code, you can return optional, you can return expected, but the problem is though is that it might not make sense for the caller to handle that error. Like that error might not be suitable for the caller to handle. So you kind of have to tramp that whatever object you've returned all the way up the call stack till someone can handle it, and but an exception does that for you without all the extra mechanics. Like that's literally what an exception does. I'm not saying, and someone's just said this on Twitch, I'm not saying that the implementation of exceptions in C++ is perfect. There are issues around the typing, but for me, like, I think it is the correct way to handle errors. You're basically saying something has happened, I cannot continue, I cannot meaningfully recover, I'm going to throw this up and let someone else deal with it. And I just think that makes the code a lot cleaner to deal with, because you don't have to worry about accumulating different error types and sort of what happens if, you know, a library you use gives you one error type and you need to kind of munch that into your sort of global collection of error types. And I just think it is, for me, the correct option. Now, there is obviously some performance implications around that. They are ostensibly, at least on x86, free to not throw and expensive to throw. If you've thrown an exception, then you're probably already in like the unhappy path, so maybe you don't care so much about performance. I would agree. I would say just be pragmatic. Like if you're in a hot loop, right, a super latency sensitive hot loop, then sure, you might want to use exceptions there, but at that point, you're probably not using malloc. You're probably doing a whole load of other weird things because you have to at that point. So it's not really like general program at that point. You're hyper optimizing for a hot path. So, you know, you got to be pragmatic at that point. But anyway, that's kind of my high level view. I sort of say this every few streams, and I think I'm reasonably consistent with my points, even if people don't agree with me. Let's create let's create a frame buffer then. So GL create frame buffers. One handle. So that should create the handle for us. Let's see where we are. I'm missing some header files here. So I'm just gonna mark these as my favorite, maybe unused, just so I can get this building, so I can update my stupid compile commands file. So again, like there's the argument that again, I'm not an expert on this. Like this is largely just me like programming in my style and my opinion, and you know, hopefully there's something for people to find interest in and maybe learn something. Like I think programming without RAI in C++ is I don't like to say wrong because it's quite a polarizing point, but like RAI is the reason to use C++. I think in my mind. The fact that, you know, your compiler will automatically insert for you all the undo commands for whatever you've done automatically on every path out is just so much safer and easier than remembering to do it on every single elf branch and every single return. So I think like even if you weren't using exceptions, you should still use RAI, in my opinion. Like that is one of the good parts of C++ in my mind. That kind of deterministic safety and handling of resources. But, you know, that's just, you could argue all day about this, and, you know, that's, I can really only offer like my opinion on it. There'll be loads of people who disagree with me, and that's fine. Like, you know, you program, if you want, like, at the end of the day, it doesn't really matter. Like, programming is a tool to deliver value to a business or your personal projects. So if you are delivering value in a way that is maintainable and meets the requirements, then it doesn't really matter whether you throw an exception or return as to expected, right? As long as you're, I would say, consistent and, you know, consistent, right? And it's maintainable. It doesn't really matter. I would prefer to throw an exception, and that's me, my reasons for that. No, there's no hard feelings, and I'm just like, it's just something I'm super interested in software engineering and like paradigms and just the different way people approach problems. And I would never say that what I do is the right way, but I like to hopefully think I can at least provide some justification for what I'm doing. If people don't like that, like, it doesn't matter. Like, you know, you like, if you're delivering value to your business, then you do what you need to do, right? Okay, right. So I've created a frame buffer. I now need to create some textures to attach to it, and then we should be able to do. Let's get up OpenGL. Let's OpenGL. Where is it? GL bind frame buffer, is it? GL bind frame buffer. So I want, where's my frame buffer functions? Okay. FL, GL, bind, frame buffer proc, GL, bind, frame buffer. Save that. Made that mistake before. So now I should be able to do GL, bind, frame buffer. And I'll pass in the, I think it's GL frame buffer, and then handle. And then to unbind, we'll just effectively just rebind the default one. I think that's what we want. So yeah, I think Graphite Master on Twitch makes a good point, and it's one of the ones I normally make, but I'd forgotten to make, so thank you very much. You can't meaningfully the only way to communicate an error through from a constructor is to throw. The alternative is to, because C++ gives you all the alternatives, right? You don't have to do that. You could you could make the constructor private and then have a public static factory method which returns it, which then returns it as like an optional. That's fine, you can do all that, but then like, what if you want to store that in a unique pointer or a shared pointer or a boost smart pointer or the C++ 47 best pointer when they come out with it? Do you know what I mean? Like, you can solve all these problems, but you're just writing more and more boilerplate and a larger surface area for potential mistakes when exceptions would just solve all that for you. Yeah. Again, C++ is one of the things I like about C++, which is also one of the problems, is that it kind of is very unopinionated in the code you write, and kind of just gives you all the tools to come up with whatever solution you want. So, which is, you know, both a blessing and a curse. Okay, so we've got a frame buffer. I hope. We'll see what happens. Now I need to bind some textures to it. So we're going to need to go back to our, let's take a quick detour back to our texture class. At the moment, we can create a texture with some data, a width and a height. We also need to be able to create a texture that is doesn't have data, but just allocates a size, because we don't want to pre-fill in the render buffer. The whole point is the renderer will do that for us. It's rare enough to have this kind of conversation, not have it be heated. I hope that's kind of my goal, right? Like, I really don't mind having. I really enjoy having these conversations. I have these conversations at work quite a lot because, again, it is quite a polarizing topic, and not everyone has the same view as me. And I think there's something to be learnt. Everyone has something to learn by just listening to the other side and not saying this is the way it should be. However, this is for this project. This is my code, and this is the way it will be. But I'm happy to have that kind of. I think it's fun to have that kind of discussion around it. Oh man, tabs versus spaces. I use spaces, but it's wrong. I think tabs is the right answer, and I'll just leave that. I'll just leave that there for the moment. Right. So I need to be able to create a regular texture without some data, and also a depth texture. So I think what we'll do is we'll create a new enum class called texture usage, and I think this will help us out a bit. So we're going to have frame buffer texture and a depth texture. I think that's what I want to call them for the moment. And then we'll have a new constructor which will have a texture usage, and then a std uint32t width, and then a std uint32t height. Okay, so basically we're going to be able to say, hey, I need this special type of texture with this width and height. Everyone else can kind of give it data with that width and height and get out what they kind of want, which is a text you've loaded off your hard disk and you want to sample in a shader. We might need to add a texture usage to this later, but we'll see. Excuse me, we'll see how we get on. Oh, a lot of talking today. So yeah. I'm going to want to implement this, aren't I? I'm just sort of staring at it. And I just don't think, no matter how hard I stare at it, the CPP file will fill itself in. I could be wrong. Alright, let's put that here. Texture. Oh, I had caps locks on then. That absolutely ruins. I might disable caps lock in Vim because I very rarely need it, and it just makes an absolute mess of my code. Okay, so let's think about this. So we're gonna want to. We're still gonna want a handle and delete the texture, and we're still going to want to actually create the texture. I think. Is that right? Somewhere along the line we need to. Yes, but the geotexture storage 2D will change. So for this. Let's do switch usage using enum texture usage. So now we can just do what do I call it, like frame buffer case. Bring this up. Oh my goodness, what am I doing? What am I doing? Right. Okay, so do I want it just to be RGBA? RGB? I don't need an alpha channel for this. I think we can get away with just this. Okay, and then that. And then I need to go and look at what the magical rune is for depth. I think it's GL depth component. So the question is, will not having an alpha channel mess up things up for textures that do have alpha channel that you load? This constructor here is not supposed to be called with loaded data, because in fact there's no way of specifying it. This is for allocating a texture on the graphics card with a fixed size and with a known size and format that we will then render into later. So this basically allows us to create a color buffer and a depth buffer. If you need texture data with different components, then you pass that in here. SDB will figure that out for you, and then here we handle the different formats, whether it's RGBA or RGB. I think, famous last words, but I think that's all we need. So we go back to our frame buffer, and in fact, actually, I think here we're going to want texture. So now we can, the frame buffer will have a texture, color texture, and what is going on? A depth texture. So it will own those, and then from here we can go nope. Color texture, texture usage, frame buffer, width and height, and then FC CTU depth, F frame depth. Okay. And now I think we need GL named, oh my goodness, frame buffer texture proc, GL named frame buffer texture. Okay, so now we can go down and we can do GL named frame buffer texture, and our name will be the handle, and then we can go GL color without the U, which is upsetting, attachment 0, because we're only going to render out one. So you can have something called multi-target rendering. I can't remember the specific MTR, which you can in one shader you can render to multiple buffers at the same time, which is useful if you're doing something like a deferred shader. You can like write out the normals to one and the color to another and all the other stuff. So, but we just have one attachment for this. Is the colon unique to C? I think this is C. The colon is unique to C++. C has no concept of the scope operator. Everything is global. Can you have typed uints similar to how you have typed uints in C#? I mean, I could create a struct and wrap around it, so there's nothing to stop me doing that. I've just not. MRT, multi-render targets. Thank you. That's what I was looking for. I knew someone would know. I'm glad someone out there knows what they're talking about. Multi-render target, yeah. I kind of knew what I was talking about. Okay, so now we can do color texture dot native handle, and then what's the last argument? Is it flags? Level. Oh, bitmap level. Okay, well, we are. avoided doing bitmaps so far, so why start now? And then this will be the depth attachment. I'll do a recap of what all this is doing in a second. Okay. So what we've got here is we've created a frame buffer. We've created and effectively allocated some space on the graphics card to hold the colors and the depth, and then we've attached those to the frame buffer. So now if we bind this, in theory, if I've done anything right, which I almost certainly have not, all following render commands will render to this buffer. Oh yeah, this is a ligature. This is a font that I have, so it just makes things easy. So you kind of get nice things like not equals becomes like that, and if you're doing TypeScript or JavaScript, then you get the not equals equals. You get that. I just find it easier to read. Stream is glitching. Can anyone else confirm? Okay, so let's remove. I've written a lot of code, not actually compiled it. So let's try that. Cool. Okay, might have been a blip. Oh, YouTube has just given me an error saying it's not receiving enough video to maintain smooth and then cut out. Okay, well that blends, so it must work. Let's try rendering to this. I'm just trying to think where I'm going to want to... I haven't really thought this far ahead, where I want to slot this into the current architecture. I guess the renderer should own it. I'm just going to stick it in the renderer to start with. It might mean that we actually, for more flexibility, kind of dependency inject it. But let's go around this. I'm just going to call frame buffer FB. I really wish it would stop auto inserting that. Right, so we've got an FB. Guess this will. But then I'm going to have to put in the size and height. Right, okay, let's let the renderer be constructed with. Oh, do I even like that? I guess the question is like, who owns the? I want to render everything to an intermediate frame buffer and then put it to the back buffer. I think a user of the code and the renderer doesn't care. I think this is like kind of agnostic to it. You just want to create a renderer and then give it a scene to render. So that's. But I will unfortunately need to leak some information. So let's do std unit 32t width std unit 32t. Height. Let's create a width. Ooh, Christ, I don't even know what I did there. Oh, and it's all gone. Okay. Okay. Oh yeah, so I'm using the MSVC Wine compiler on Linux to cross-compile for Windows, but this is a WSL instance, so something Windows WSL magic, I can just launch a Windows executable from the WSL command line and it just spawns the correct Windows process. So I kind of get my nice Linux set up with NeoVim and Tmux and all the bits I like, and then I can just kind of cross-compile using the actual Microsoft compiler. It kind of works for me. There's a few quirks around it, especially around some of the like ClangD autocomplete, but so far I quite like it. Okay, so this is going to be grumpy, so let's ungrump this. Stdint, and then I'm going to want frame buffer. Okay, stirred uint 32t width, stirred uint 32t height. And then FB will be width. Again, this is kind of like the advantage of abstraction, you know, just kind of all that horror of building the frame buffer and then having to allocate textures and do all the depth buffering is kind of just hidden behind a simple constructor now. So, you know, that's why we abstract things. What does the arrow operator do? Because C++ is chronically short of tokens, the arrow has different meanings depending on is overloaded depending on the context it's used in. So here, this just means the return type of the function. Arrow on a member will invoke the operator arrow method if one is supplied, or if it's a pointer, will dereference the pointer and call that member on it. So it is a little bit confusing. It kind of depends on the context that you're in. Oh wow, someone said that they have reached someone, they know someone at Team 17 who's watched my Worms 2 video. That's really cool. One of my favourite childhood games, so I find that cool that someone there has actually watched it. I'd be interested to know how much of it I got right. Some people, I've had a few like devs from games reach out to me before and kind of tell me what I got right and what I got wrong, which is always fascinating. I love that. It's like a good result for me. But yes, I'm cross-compiling from Linux to Windows on Windows. It works for me. Do you know what I mean? Like you got to find your own workflow. Okay, so let's think about this. When we're going to want, on each render pass, we're now going to want to do fb dot bind, and then at the end we're going to want to do fb dot unbind. Now I think I can blit the frame buffer to the standard buffer. So what blitting does is bit level transfer. It's an operation which basically takes a chunk of graphics data from one buffer, frame buffer in this case, and just like very efficiently copies it to another. So I should be able to blit everything I've rendered into my custom frame buffer to the default buffer, and then that will then appear on the screen. I think that's right. We're sure going to give it a go. If anyone out there actually knows OpenGL, do let me know if this is a fool's errand. But I think I want GL blit named buffer proc, GL blit named frame buffer. Oh, this here is, it doesn't, I can't remember specific, it doesn't like my custom aligning of each element, because we have to align this in the same way that OpenGL is expecting it, and it got grumpy about this, so I just disabled the warning. I can't remember what the specific warning was, but it was to do with manually aligning individual members. Yeah, MSVC one's on the alignment. I'm not quite sure why, because this is absolutely legit code as far as I can tell. Like this is well defined. I can't remember what the warning was. I think it was a warning like, oh, this might not be efficient, or something weird like that. It was a very strange. It was a very strange warning and quite irritating. Inconsistent camel case on frame buffer. You're gonna have to give me more details on that. Oh, because OpenGL does it with a lower B and I do it with an upper B. Yeah. It's consistent in my world. So let's do GL blit named frame buffer. So this has quite a lot of arguments. So we the one we want to read from, the one we want to draw from, and then basically all the various X's and Y's and destinations and stuff like that. So we're going to do that now. I might need to change frame buffer actually to make, it probably needs to know its own width. And its own height. I'll implement those. What I'll do is I'll implement these in a second, and by in a second I mean I'll forget to get a linker error and wonder what's going on. So the read frame buffer is FBO.native handle. Now this is the bit I'm skeptical of. I think 0U is the default, is the name of the default buffer I want to draw to. I have both frame buffer uppercase and lowercase b. I'll keep an eye out for that. I shouldn't do. Yeah, I thought I named it FB. I did name it FB, thank you. Right. And then X, Y. Oh, God, what are these? So specify the bounds of the source rectangle within the read buffer of the read frame buffer. So I want source X to be 0, 0, FB width, FB height, and then on the destination side I want the same. This assumes you've created a frame buffer. Well, we know that because we'll take the width and height in the beginning, but it assumes you pass in the right width and height. I suppose you could, if you want, I'm waffling, but hang on, let me just, if we wanted to ensure from a programmatic level that this was the size of the window, then we could actually pass in the window object and then pull it from that, because then there's kind of no arguments then. But I didn't think about that, and here we are. So I want GL color buffer bit. I don't think I want to copy the depth buffer over. I don't think there's any point. I don't know which one of the interpolations I want. I guess I want GL. Shouldn't actually matter, right? So we'll do GL nearest. I will do post-processing eventually. I want to do SSAO and maybe some others. We might do a little post-processing effect here just to kind of prove it works, but we're already kind of like an hour in and we're not even gotten close to HDR yet. We've still got to debug all this. Yeah, so we are rendering to the frame buffer just to blitz it to the screen, just to check that the mechanics work, and then what I'll probably do is replace this with a little post-processing shader that maybe just does grayscale or something, just to kind of prove, just to set up all the machinery, and then we'll go back and we'll add floating point frame buffers, and then we're kind of already set up then to add a tone mapping post-processing step, because we've already made a little post-processing step for ourselves. Yeah, we're gonna do all that. I just, again, I don't like to do too much in one go because it's a pain to debug. I'd rather just add little bits and check it as we go along the way, and then add more and more stuff as we get along. So yeah, you're basically going to render. Well, we will end up rendering a full screen texture. This isn't. I would argue this isn't technically rendering a full screen texture because we don't have a full screen quad. This is just taking all the bytes that we've rendered to and like smashing them into the frame buffer. Anyway, let's see if this runs. What I might do is I might bust this open, if this works, or even if it doesn't, I might bust this open in RenderDoc, and we'll see. Ooh dear, where we've gone wrong. Oh, of course, I haven't passed in the size into here. Let's do window.width and window.height. And then I must actually go and implement these frame buffer. So I'll need to store these as variables. Let's do those first. Let's do those unit32t width, height, and then we can go width height. And then we can just super quickly implement these. No problem at all. Barely an inconvenience. And then right, okay. Then we're good to go. It's a background. It's the NVIDIA background removal tool. I thought I'd give it a go. So it's not a floating point buffer for the frame buffer at the moment. It is just a pure RGB frame buffer. What have I done wrong? I have... Oh, interesting. It can't find one of my OpenGL functions. Which one can it not find? Could not resolve GL create frame buffer. Oh, is that because I've... Is this what someone was telling me where I've been inconsistent? Oh my goodness. Frame buffer. CFB frame buffers. Right. Oh, Christ, what have I done? I've recently switched my bash into Vim mode and I'm not used to it, so I'm kind of learning this as well as I go along. No, it's fine. You're absolutely good. Do 2 things at once, do 3 things at once, do whatever you want. Just have me droning on in the background. Ads are enabled on the live, yes. God. Right, now, oh, because I used the autocomplete. Right. Where am I? And should be able to just press dot and it fixes it, I think. Nailed it. Oh, it took so long to load these assets. Definitely need to fix this in the future. Oh, I did not like that. Okay. Internal format not supported from texture. Okay, texture line 48. See, again, advantage of exceptions. I can just print the stack trace and I know where my error is. Texture 48. Can I not create a GL texture 2D? GL texture storage 2D? For a depth buffer? Is that not a thing I can do? Oh, have I got to be more specific? If I got to be like, oh, I actually want GL depth component 24. Like, I want 24 bits of depth. I think that's the problem, because you can have different, what's the word? fidelity in your depth buffer. You may say, I want 16, 24, 32 bits of precision, different levels of precision. That's what I'm looking for. Well, I was not really expecting that to kind of work, but here we are. Okay, what I'm going to do quick, sorry, I know that kind of flashed up and disappeared. Let me copy over this. Here, and then we open up render dots so we can just like verify that worked. Launch application, YouTube source, open, command line arguments, assets, launch. Give it a second to chug through what's going to chug through. Yeah, it was. The problem was I was using the wrong tag entirely. I wasn't giving it the supported format. I was like, I'll just have a depth buffer rather than being explicit about what size depth buffer I want. Okay, so let's take a capture of that. So now we should be able to see here we've got multiple passes. So this should render out all of our barrels. We'll get there in a minute. Let me just scroll down a bit. My goodness, there's a lot of barrels, right? So this should be slowly filling them all in. Look at them go. And the target for can I see what the target for this is? So this is the inputs. So we've got our normal map, our specular map, and our albedo map, and then the output is FBO. Here you go. This is our custom depth map. And then at the bottom we can see here blit named frame buffer. So the inputs was our source, and then our outputs was our back buffer. So you can see here this is kind of working. I'm just going to comment this up quickly because I think this is quite an important, kind of a good point. Okay. Commit extend texture class. And then, as always, my very lazy integrate changes. Okay, cool. So I think what we might do now is introduce a little post-processing step so we can kind of see this more in action. So what we'll do now is rather than just blitting, as in just copying verbatim the whole frame buffer from our custom one over to our destination screen buffer, we'll actually use it. We'll actually create another. We'll actually render a full screen quad. So that should be 2 triangles that fill the whole screen, and then we'll texture that with that previous render target. And because we're sampling it, we can actually write a shader which interacts with that texture. So we can make it grayscale, for instance, or do edge detection, or blur it, or what. The sky's the limit. So I'm going to try and put that in because we're going to need that at the end anyway for something called tone mapping. But we'll get there. We'll get baby steps. We'll get there one bit at a time. We could use a whole screen triangle with some hardcode UVs. I'm going to use a quad because I feel that's more canonical. Possible. I'm not too fussed about optimizing it, but that's interesting. I never thought about that. Let me just find. Right. Okay, so what we're going to do is actually go to our mesh loader. So we've got an auto cube here, so we're going to do an auto sprite. And then, so this will then just allow us just to create a sprite object easily, and then we can just use that for rendering too. Am I going to need... I hadn't thought about this. Am I also going to need orthographic projection? Maybe. We might need to adjust the we might need a separate camera for rendering this as well. We'll see how it goes. Okay, so let's go to our mesh. Hang on, sorry, let me just take a copy of that. Mesh loader. Okay, so somewhere below cube, we will do mesh loader. Yeah, but also orthographic, because I just want to render could just write identity matrix in the camera buffer bits of you. Oh, that's true actually. Yeah, we could just hard code it. We'll see how we get on. But yeah, you're going to want some sort of orthographic project. That you don't want perspective because you're rendering a quad that fills the whole screen, and it should always be the same distance from the camera, right? It should fill the whole screen. It's effectively a UI. Thanks AC for another Prime subscription, much appreciated. Yeah, we'll just hard code it because we're going to have a custom shader for it anyway, so we can kind of optimize it a bit. Okie dokie. In fact, actually, yeah, I don't know why I'm even worried about that, because you just wouldn't have a perspective or view matrix, right? You would just have a model matrix, I think. The benefit of the full screen triangle is that your fragment shader runs on 2x2 pixel quads, and the shared edge along the quad means that the fragment shader has to run twice along that diagonal. Interesting. I hadn't considered that. Again, I'm not aiming for super optimized code. I'm just aiming for kind of simple code that works, and then we can profile it and optimize it later. I'm sure there's a billion tricks we can do to like squeeze out the micro and millis and the nanos, but we'll see. We'll see what we get to. I'm gonna like do the unthinkable and just steal a bunch of this, because this is basically what I want anyway. So we'll call it cube. We'll call it. So this is just a simple like cached mesh loader that we built a couple of streams ago. So we want minus. I'm just gonna. I've got what I need in some notes here. So I'm just probably just gonna hard code it. So minus 1.0 f, 1.0 f, 1.0 f. Four. Okay, so we've got -1, -1, and then 1, -1, and then 1, 1. Then the normals I don't care about because we're not doing anything fancy for that, so I'll just cheat and pass the positions in. I know they'll be wrong, but I don't care. And then the UVs will be 0.0 f, 1.0 f. And then we're going to go 0, 1, and 1, and 0. And then the indices will be 0, 1, 2, 0, 2, 3. Yeah, I think there's a million ways we can do this. I'm just going to get something that works, and then we'll, like I said, we'll see where we get to. So we've got this load mesh templated thing that we wrote last time. Don't worry too much about it if it's all seems a bit strange. But basically it allows me to pass in views of attributes of the vertex data, and it will automatically zip them all into a vertex data struct. So I just have to sort of make sure I supply them the right numbers in the right order, and it all kind of works out. That's wrong. I don't need, of course, yeah, I don't need normals or tangents, so I'm just going to pass in the same data. It's a little bit wasteful, but again, I'm not optimizing for that at the moment. So that should be what we want. Let's try that. So let's do, let's do my simple vertex shader. I think I'm trying to think if I need the projection or not, because I don't have a square screen, so it will have to do some camera transformation, right? And it will still need to know the width and the height. So I might just pass in a projection. I don't. Let's just start writing something and see where we get to. Postprocess.vert. Okay, so in my postprocess, I need all this because it's just what the vertex data looks like. Pass a projection. You could also have your vertices being clip space -1 on both axes, and an identity projection. That's already the. Is that not already the case? These are all -1 to 1 positions, right? So I'm wondering if I can just get away with this. All right. So then I don't even need to bother passing this, right? I don't even need this, because this is going to, my renderer will just know that this is the final stage, and it'll be like, sure, I'll just render this across. We'll see what happens. Well, it could even work. So simple frag, and then source, nope, assets, post process frag. And then I don't need I just need one sampler, right, for the frame buffer. Don't need this, don't need this, don't need this, don't need this. And then we can just do need to move the outs. Yeah, we're going to tidy it all up in a second. There's, yeah, I've missed something. Let's do. So can I do texture text? Sorry, text naught, text quad. Can I swizzle GGG? Because what I'm trying to do is the human eye is more sensitive to the color green. So if you just spread the green component over the RGB, it'll be in grayscale, but it's a good approximation for luminance, like how bright the scene is, just because your eye is more sensitive to green. It's not perfect, but it's kind of it's like a really good rough approximation. So I thought that might be kind of a fun post-processing effect. It will look grayscale, but it will be kind of highlighting the brighter areas. I think I can swizzle like that. If not, I'll just do it the hard way. But I think so. Someone was saying I might have missed something in the post-process, that I don't need normal correct, and I don't need the TBN. Okay, so if we go to our renderer, we will need much like we had a skybox cube and skybox material, we'll need the same thing. We'll need a mesh for post-process. That's not how I want to write any of that. I hate all of that. Post-process sprite, and then we'll have a material which is a post-process material. If I ever wanted to decompile a game, or have I decompiled a game? I've decompiled quite a few games. I've got loads of videos on it. Do I use auto? I use auto basically everywhere, unless I am dealing with something which is sensitive to the type size. So, for instance, serialization or networking, or like, I know I definitely want this to be a uint64T or a uint32T. Then I will specify the type. Otherwise, I just use auto everywhere. Again, you could spend days arguing about that and get nowhere, but that's my opinion. Okay, so now we need to post-process sprite should be mesh loader dot sprite, and post-process material should be, I have to use a function for this, don't I? Let's do, I'm glad I've already got this wired up. So we can do cube and call it, what was it? Post process. Right. Okay. That should be fine, and then that should be create post process material, pass in the resource loader. Right, I think jobs are good. So now, after we've rendered this, instead of blitting to it, because we've unbound it, the active frame buffer in the state machine should now be the default one. So anything we render should in theory render to that. So I think we can basically do post process sprite it's not bind post process material dot use GL draw elements, GL triangles, post process. I'm just copying the code above, by the way. If I look like I'm a bit confused, I'm just trying to get it right. Post process sprite dot index count, GL unsigned int, reinterpret cast, my favorite, to avoid star, even better. Post process sprite dot index offset. This is just chuff we've done before, so it's not too bad. And then post process sprite dot Unbind. Okay. Where is it not like that? What have I done wrong? Triangles and unsigned. Okay, could even work. Could even work. It's pretty good to me. Probably gonna have to render doc that. So reinterpret cast is just you telling the compiler that this pointer or reference type is now actually this pointer or reference type. It doesn't emit any code. It doesn't cast. It doesn't convert anything. It literally just says when the code is running, this type is now this type. Because of that, it is riddled with undefined behavior. It's really easy to get wrong. What this is doing is basically saying this integer here, right? This returns a number, but can you please treat it as a pointer, as if that address, so say this returned 27, it's basically saying, can you please turn this into a void pointer pointing at address 27? Obviously that doesn't make any sense. Very unlikely OX27 is going to be a valid address, but just the way this API works, it expects it's basically a way of packing a number into the space allocated or reserved for a pointer. It's a bit gross and it's a bit gnarly. I wouldn't stress too much about it. You can kind of just assume this is the runes you need to draw in the sand to get OpenGL to work. Or not in this case, because it's not working. Let me just copy that back over. And copy the assets back over. And we will hopefully be able to just relaunch this. But, well, I mean, you can't reinterpret cast uint64 to a uint64t because it has to be a pointer or a reference type. But what you're talking about there, this is on Twitch, is basically is stood bitcast. Capture that. Okay, so this is the beauty of RenderDoc now. So we should be able to see. So we can look. It's still doing the rendering. It's still rendering everything out. He says, right, and it's going to our FBO. So that's all good. Now here, oh, is it not? Is it just not? Hey, I didn't get to save it, did I? I can't. What am I missing? So this loop here is all these GL draw. So each of these GL draw elements comes from this loop, but it's gone on to the second color pass, which, as you can see here, is the ImGUI output. So I don't understand where this has gone, because we definitely ended up with a black output, right? Like that was, we all saw it. Hey, I can't even see that GL, this call to GL draw elements, I can't even see. Let's launch that again. No, it won't be no, because this tells you, this number here is how many triangles it rendered, and our sprite is only 2 triangles, not 4,200. Let me just check I'm not going mad. We definitely have a black screen. Okay, so we definitely got that. Checking the log, I didn't miss anything. No, I can see it's loading. The log isn't logging anything. So let's F12 capture that. Okay. Quit that. We GL clear. GL, we draw the skybox, see 36 triangles, that's the skybox. Draw all these. I don't know. So, sorry, there's a... Check out the back buffer image in the resource inspector. Let's see if we can go through the history of a black pixel. So I've got the back buffer color. That's what I want, isn't it? View contents. Resource inspector. Back buffer. Remove the which filter? You've gone beyond my here you go. No, it's we can see it. We bind the sampler, we call uniform, we bind the vertex, right? We draw the elements, and then just stop. Like where's this? I didn't build it, right? Like, I'm not... Is it actually loaded that other... Can I see all the loaded shaders? Do I need to clear? Do I need to call this again after this? No, let's just copy it around. Like, how are people finding the cutout of me in the bottom corner? Preferring it to this? How are we feeling? But why is the event not there? Like I've programmed. Oh, I have to put some logs in. That is better. Is that better? Like, let's do like post process bit. Doing post process stuff. I need to set the out element in the vertex shader post-process. I thought I'd done that, but I will go through and double check. I mean, it's doing post-process stuff. Okay, let's go through and verify what we're doing. Okay, it's the easiest thing to do. So we create the post-processing material, post-process vert, and post-process fag. Okay. We create a sprite. Then at the bottom of render, we unbind the FBO, which binds 0, which should be the default one, and call use bind GL draw elements bind. But the weird thing is that the GL draw elements is not showing up in render doc. Yeah, I think so. That is right. I just can't bother to add those functions to OpenGL. I want to see if this GL clear comes up. I think that's kind of equivalent. But yeah, otherwise we'll improve our logging. Let's just double check our. Oh, hang on. Do I not need to do something like text chord equals in UV? Like that, like it's not gonna like that regardless. I haven't decided whether floating circle is going to be gone or not. I might mix it up. I'm just playing around with something new at the moment. Might as well put my 3070 GPU to use. Oh, hang on. I'm not. Don't I actually now need to bind the. I need to bind the textures, right? Post-process material, bind textures. What's the? Do I need to bind the underlying texture, or do I bind the frame buffer handle? Do you see what I mean? Like, I need to pass a. I think. I think I now need to do auto texture, color texture, const texture reference. Okay, and then I think I want to bind textures. Bind texture 0 FB dot color texture dot native handle. Differing opinion on whether the floating me is better or worse than the circle. I like the circle because I feel it's more like, I don't want to say branded because that sounds terrible, but do you know what I mean? Like, I have like all my videos have me in a pink circle, and you know it's kind of consistent. I'm probably going to keep for the rest of the stream, and then I'll see how I feel. I might mix it up. I'm not convinced I like this at the moment, but I just wanted to play with something new. I will admit the lighting. I think the lighting is worse here than here. I think like the hue kind of makes more sense with the lights, but we'll see how I go. I might just move the circle down to the bottom because I think it's less in the way anyway, but we'll see. Yeah, I was just sampling whatever happened to be bound previously. Okay. Frame buffer. Let's do you there. And then return color texture. Okay, let's see if this works. Missing elements and bind textures. Oh, I need a sampler. Oh, bane of my life, this. I'm going to cheat because I don't actually have any proper samplers set up yet. So what I'm going to do is I'm going to write what now will almost certainly be a bug, a really insidious bug to find in the future, and reuse the skybox sampler. Oh, I know about that. Where's the skybox sampler? Oh, is it just stack allocated? So that's a bug for a future stream. We'll just save that there. Like that, did it? Oh, because I need to. The whole point of the abstraction is that I don't pass around OpenGL primitives in my API. I pass around my abstractions, and then internally they pull out the OpenGL gubbins. There we go. That's what let's see. Okay, so now we've got what is effectively an approximation of brightness or luminance in the scene. So if I had, oh, thought that would adding more lights would affect that. Is it because they're red? I guess because they're pure red. OBS Studio is disconnected and now reconnecting. Is anyone still out there? Hello. It was reconnected successfully. I will let everyone out there be the judge of that. Is anyone still out there? Hello. Wow. I think YouTube might have actually had a bug there because all the YouTube chat messages stopped coming in at the same time. So I think it was actually, I think it might have been YouTube's end, because once the stream reconnected, all the messages flooded through in one go. How strange. I don't know if anyone on Twitch is still out there. Very disconcerting when the chat stops. Okay, cool, thanks. Apparently anyone on Twitch just needs to refresh it. Okay, cool, I'm pleased with that. So let's now think about HDR. Oh, the background doesn't like, the background removal tool doesn't like the glass. Okay, so At the moment, our frame buffer new YouTube member, Trevor, welcome. Glad you're here. Okay, so our frame buffer. Oh, how do I load textures? I am using a header-only library called SDB, which I believe basically everyone uses. What I'm going to do in a future stream is actually rip all this out, stick it in a separate utility, which processes all the textures ahead of time, reads them, formats them so that the game can easily understand them, and stick them in a binary file. So then basically after that, when the game loads, it will load that binary file and basically just like mem copy it straight into the right hole, and it'll be super fast to load. That's the plan anyway. We're probably going to do that next. If I can finish HDR today, that'll be next stream. Morning in Australia. How's it going? I won't do the accent. Okay, so at the moment, in our render texture, in our frame buffer, we are creating a texture, and I should probably actually go back to where I was. In our texture class, if we are using this constructor, which doesn't take data, it's just for purely pre-allocating space on the graphics card, we are using an RGB8 format for the texture data. So again, we've still got this issue where every single pixel value RGB can only be 0 to 255, so there's only 256 options, and we want a bit more fidelity, a bit more precision than that. So to do that, we need to change this into a floating point buffer, which will then give us a larger range of values, and then we'll need to map those back to the 0 to 255 range at the end, because what you actually kind of send down to your graphics card is expecting it just in that range. I don't have a HDR monitor or actual real HDR output. You'll see what HDR does. What HDR basically does is it allows you to represent a larger range of colors, and then you use something called tone mapping, which gives you kind of like a specific feel of how you map like a high range of colors to a low range of colors. Because if you just straight up cast them over, it'll either look the same as if you've not done it, or just look weird. But you have different what's called tone mapping curves, which give you like a certain feel. You can think of it like how certain old school like film, like you put in a camera, had a certain chemical composition which would give you a certain like color grading at the end. So cinematographers would prefer to use only Kodak film or Canon film or whoever was manufacturing, because they like the feel of it. Tone mapping is kind of like our equivalent of a film stock. It'll give you a certain feel, and then you can alter it to give your scene a different look, like preserving different ranges, because you've only got 0 to 255 for each RGB component. So what do you preserve? What do you prioritize? Do you prioritize like highlights or lowlights? Do you sort of crush the blacks down and give a higher range to the highlights? You'll kind of see how it works as we go along, but it kind of will it will stop all the colors blowing out and basically capping out at 255. It should, in theory, allow us to have more lights in the scene and still preserve a lot of the texture details. And then we have to do like camera correction, a whole load of other stuff as well, which is just kind of part of it. But we'll see how we get on. Let's see. How do I create a thing? So what I want here is this is why I specified frame buffer, because I want to be able to say when I'm having a frame buffer, I actually want RGB 16F. Okay, so this is basically saying I still want RGB, but each one is now, rather than being a unsigned integer byte, it is now a 16-bit floating number. So this will give us a much wider range, because rather than having a sort of a finite 0 to 255 values, there's now whatever 0 to max 16-bit float is. Let's just see if that works. Actually, and I'm gonna undo the post-processing effect for the moment. Okay, so that is kind of what I expected, in that it looks the same, because it's basically, we've rendered everything to a higher range and we've collapsed it back down to a lower range. So if I keep adding lights, we still get this weird blown out section. So what we now have to do is we have to do the tone mapping. So I'm just going to repurpose this post-processing one, because it's already set up to do that, to do the tone mapping, and then I'll just rename the file later. So let's make 3 high HDR color is that, and then we'll do. So Twitch is on a quick break, so I'll start typing up some of this, and then we'll come back to it in a second. Oops. Oh, hang on, what's going on there? What? Where's all my code gone? I literally... I'm having a weird, funny moment with my tooling here. Alright, okay, fine. I'll explain this code in a second. I'm just typing it out. Okay, so what is all this chuff I've just written? Basically, this here is the tone mapping. This takes the HDR color that we've got in our floating point frame buffer and does some maths to it to map it back to the standard low definition range, but preserving certain characteristics of it. It basically balances out, kind of evenly balances out brightness across the whole range, which means it should preserve details in the highlights and the lowlights, and kind of give us a fair amount of detail. This is known as the Reinhard tone map. It's kind of like my first tone map. Everyone who does tone mapping probably comes across the Reinhard one first, because it is super fast and super simple. It's literally just that. I actually have another reason for using, it's the Fong of tone mapping here. I have another reason for using Reinhard, personally for me, in that Eric Reinhard was one of my lecturers at university, so I kind of feel it's kind of nice to use that, kind of throw that in there, just a little name drop there for everyone. But yeah, it should give us some half decent results. There's a good, like, see if I can find it. Yeah, Bristol. He didn't teach me graphics, he taught me data structures and algorithms. There's a good article somewhere of the like comparison of the different tone mapping algorithms. I'm just trying to find it now. I can't find it. I should have pre-prepared. I should have prepared this beforehand. I just gone really dark. Is the oh no, it's not that it's disappeared. It's just I don't know what it's called. it's the I'm pretty sure the article still exists. I just don't know. I just don't know what it's called. Versus Unreal. Oh well, if I find it, I'll post it. Maybe put it on a community page because it's really interesting. It kind of shows you that visually shows you the difference because I can't bother to implement it anymore. Anyway, let's just see if that works. And then no, it was. It's really annoying me now. I can't find it. Oh, is this it? Yeah, this is it. Okay, fine. Found it. It kind of gives you more of a view of like the actual maths behind it and like how the different curves work. We got this as the Reinhardt one, which is basically what we implemented. So it's the high definition divided by 1 plus the high definition. But I don't know. I don't know if it's particularly obvious here, but this article, I will post this. Let me post this as a link in the various chats. There, and then where's the they're kind of quite subtle, but there's a whole different ones here. Unreal have their own one. Aces have their own. I can't remember what Aces one is. It's used in certain games. Oh, they've all disappeared for me. There's loads of different ones. But yeah, this is kind of the example that I was referring to here. Is that you can see how all the multiple lights here have kind of blown out all the colors. But when you do proper tone mapping, you get this. So it preserves all the details and like nicely lights it. And then gamma. Right, I'm going to try and explain this, but I always get this one. I'm not an expert in this, so apologies if the details are not like totally 100% accurate. I'm sure someone out there will correct me, but basically, when you used to have CRT monitors, or at least like I remember having CRT monitors. There's the curious property of just how like the laser in it worked is that doubling the number of electrons you fired at the screen didn't double the brightness, just something physics. And it actually went on like a curve, like an exponential curve. So, but everyone kind of works in this thing called like linear space, where like you want the idea of like doubling the output to double the colors. So CRT monitors basically applied this this curve to your output to kind of compensate for that. And then when everyone moved to LCD screens, because everything in the world was set up for that, LCD screens actually mimic CRTs. They actually adjust your colors to behave as if it was a CRT. And then because we are kind of doing all this mapping and stuff, all of our textures are in non-linear space. We effectively need to, but we are treating them as if they are linear. We need to undo the transformation so that when the monitor reapplies it, it maintains a linear color space. I think that's right. It's something to do with basically you have to raise everything to the power of 2.2 or some gamma function to make the colors appear correct when it goes on to the screen. I should have looked this up before for a better definition. I do apologize. It's one of those ones I always kind of forget the actual specific nitty-gritty details of, but you're basically, for your colors to be correct and for you to work in a linear space in the shader, which is what you want to do, you have to adjust for the transformation the monitor will do for you. Some gifted subs on Twitch. Thank you very much. Hafodov and Valorant, I think. Thank you very much. Much appreciated. Anyway, let's see what this looks like. And then it still won't be 100% correct because we're loading our textures. OpenGL will apply the transformation for you on loaded textures, which we'll then need to effectively disable because we are applying the transformation ourselves. Otherwise, you kind of get it done double. I might put that gamma in a uniform so we can like play around with it through MGUI. Okay, Valorant is a promotion Twitch is running with the game. Well, they give me 3 subs, so I can't really complain. They just pick random channels to give subs to. Where'd that go? That explode? Implicit class from Vec 3 to Vec 4, line 13. It is not wrong. What did I intend to do? If you give 5 more subs, they have bonus ones. Interesting. Well, thank you very much for giving 5 subs, because then I've got another bonus 3. Hello? Ugh. Undefined variable vec. What are you chatting about? Nope, you are right. I want that to be 3. We'll get there in a minute. Good job we've got fast compile times. Yes, asset pipeline next, I think. Here we go. Right. Now, the textures are loaded wrong, which is why the colors look a bit bright, but we should be able to add a whole load of lights. And we should see it preserving more of the detail. Like we can still see some of the texture even though we're adding more lights. Which is cool. Okay, so now I need to change, what do I need to change? I need to change how the textures are loaded to be so I need okay, so now there's a slight the fly in the ointment here, or the bear trap that we're about to step into, is that some textures are not textures. Some textures are data packed into a texture. So a normal map, for instance, we don't want to mess with any of the values. So we need a way of, when we're loading a texture from a file, to be able to disambiguate between texture data and like data. So what we can do is we can just there a minute. Right, we can. Okay, why can I not use a keyboard? Right, thank you. What we can do is we can extend this to be like I don't know, like sRGB and data. So now, and then we'll change this so it also takes a texture usage. 18G usage. Okay. I want to ensure that usage equals I'll do the range. Let's just do texture usage valid usage equals texture usage sRGB. I suppose I probably could have created a separate enum that was just for this overload, but here we are. But otherwise, the problem with that is that's all well and good, but then it doesn't give me a chance to arrange this stream. And like, is it really a stream if I've not written something? If I've not used ranges? Invalid usage. Oh, I should add that to the formatter so we can print it out, but you know, there's only so much you can do. Okay, so now what we want to do is what is that? Is that a GL enum? What's the type inside a GL texture storage 2D? Because I could actually just ask the computer. Oh, fine. I thought it might. Oh, I've locked up Vim. Oh no. Oh no. I don't really have a favorite shaded language. I guess GLSL because I know it the best, but this is dead. Oh, something has gone wrong here. Yes, I know. I would like to resume this. What? I guess I'll just start up another one, but okay, let me just, what was I doing after all that? Texture 2D, okay. GL texture storage 2D. GL texture storage 2D. It is a GL enum format. So let's do GL enum format. Auto format equals GL enum. And then we'll do switch on usage using enum texture usage case sRGB format equals num channels equals 4 GL RGB A8 GL RGB 8 break. Oh no, that's wrong as well. That's the data one, isn't it? So this will be GL sRB and sRB RGB8, I think. So then I can do CT comma format and then down to here, and then there. Is it necessary? Is it not that? sRGB alpha, obviously. Is it sRGB 8 alpha 8, or is it just sRGB alpha? Because that's what it said it had. See if it blends. I've messed up. Also, I've not integrated that into main yet, so that definitely won't work. In fact, that's exactly what it's complaining about, isn't it? Okay. I will choose not to, because it sounds like more typing. Okay, so now I want to do, so the albedo texture is game texture usage sRGB, but the others will be data, because I actually use the actual RGB values in there for a specific purpose. What's been the most difficult or time-consuming part of creating the game so far? Oh, that's really good. What's been, maybe I put, who's been in a lot of these streams? What's been the most difficult part so far? I think none of it's been hugely difficult because I've done a lot of this before. I'm trying to think what's been particularly tricky. The log, writing my own logging code was probably the most complex one because I was trying to be fancy with it and use a lot of template metaprogramming. Yes, you're right. Getting all the matricey stuff, the lower level math stuff was a bit of a pain because the code I was cribbing from was row major, so I had to invert it all to column major. And cribbing from is in like stuff I've written before, and then we got stuck in a bit where it was working, but we convinced ourselves that it wasn't working because it didn't look right, even though it did actually look right. It was sort of slightly at an angle, so getting all that stuff done was a pain. But yeah. Internal format not supported. Maybe I do need to specify the size. 946, eh? Oh no, wait a minute, I'm looking in the wrong place. Texture 51. sRGB 8 alpha 8. So when you said it was my choice, it might not be my choice. So great point on YouTube here. The linear versus gamma space, someone simply added the GL enable GL frame of sRGB to initialize method, and the output was indeed brighter. There's kind of two ways of doing it. You can kind of get OpenGL to do it for you, or you can do it the hard way, like the slightly harder way and do it as a post-processing step. I chose to do it in the post-processing step because it's getting OpenGL involved a little bit less, as in like I kind of in theory have a much better understanding of the pipeline, and I don't have to worry about when our OpenGL is going to like apply this, and it means technically I also can control the gamma value. I think OpenGL internally will use 2.2 or something similar, whereas we can actually control that if we wanted to. Texture type and format combination is not valid. What have I done wrong? I've got a it's still an unsigned byte. because we're still just loading RGB. All the floating point stuff happens in here. Let me look up the docs for this. So it's the texture, the level, the X offset, the Y offset, the width, the height, the format, and the type. So it doesn't like the type. Texture, type, and format is not valid. Why is it not liking unsigned byte? Oh, yes, you're right. I think this is wrong. This still needs to be that. I think. But I'm not loading the textures as HDR, right? I want to load them as just into linear space. Yeah, that's better. That looks better. There you go, it's not as bright now. So now we can sort of go absolutely ham on these lights. We still, I mean, it probably will clip out a little bit because it's not the best tone mapping in the world, but it will allow us a lot more flexibility on the lights. Yeah, it still preserves a lot of the details. So let's try one last thing. What the fragment shade? What the fragment shaders have we got? Uniform, float, gamma. I mean, I'm not an expert either. I'm kind of making up a lot of this as I go along, but well, I'm not making it up. I'm kind of figuring it out. Let's just see if we can do that. So let's just go to the renderer. I think I'm going to stick it in render, but I think this should eventually, or when I want to refactor this, maybe at the start of next stream, and put the skybox stuff into the scene. Rather than it kind of all just being passed in every time, but for the moment it is okay. Okay, so after we bind the textures, I want to do post process material dot set uniform gamma. I believe we will need to add another method. Yes. Float. Material. Uniform. Right. Where's the int one? There it is. I need to tidy up some of this code as well. This is ripe for refactoring and formatting because all this gubbins. But for now, it's fine. From 1F back to this uniform 1F. Oh, uniform 1. Oh, it's because it's 1I. I need to F-I-R F F-I R-F R-F R-F. And then renderer. Oh, I've already got that. So main. So what I'm going to do is float gamma. Nope. Auto gamma equals 2.2f. Let's shove this into here. We'll fix that up in a second. And then down here, we'll just pass in the gamma. So if I then go to the debug UI, gamma, float, gamma. Oh, my goodness. Right, debug. Float, gamma, and then oh my God, so much boilerplate. Getting good mileage on the keyword out of this, and then wherever we do the FPS with the add lights, let's do imgui slider float. Okay. Imgui slider float. Oh, here you go, slider float. That's what I want. And then it's gamma. Gamma. I don't know what a good range is, so it's just 0.5 to like 5.5. Stick it in the middle. Okay. See if that works. Would I say it's worth it to learn near Vim? I think it's always learning Vim is just a useful skill anyway, because you'll eventually find just, well, I say depending on what you do in your career, but quite often you'll end up on a Linux box somewhere and Vim is the only thing installed. So it's kind of useful to know it just to be able to get around. For me, I quite enjoy programming in it. I find it quite it's fun, it's enjoyable, like it's quite efficient. So it's kind of, if you want to learn it, do learn it. But I think you can be an excellent programmer without knowing Vim. Do you know what I mean? Like without using it every day. I'm not an evangelist for it. What have I done? Oh yes. Did someone even? I think someone might have even pointed that out. Yeah, no worries. I learned it at university, and then I'd now not been able to. I said, well, I did force myself to learn it at university, so I did like all my coursework's in it, and I was incredibly slow and painful. And I was like, I just pushed through it. Now, for me, I can't actually. I find it very hard to use anything else, just because there's so much muscle memory ingrained in it. Yeah. Ignore that. I literally just fixed this. What are you chatting about? Ah, what's this? Ambiguous call to overloaded function. How strange. I find that hard to believe. I find that very hard to believe. In material 123. Oh, that's okay, fine. So yeah, I was relying on the compiler to cast this into a int. That's fine. We can fix that. Nice and easy. Saving is hard. Yeah, I can do a quick overview in a second. Okay, so basically kind of lets you affect the whole kind of scene level brightness. If you see a game with a gamma slider in the settings, that's all this is doing. So it basically allows you to kind of tweak this. I'll leave it at 2.2. It's kind of interesting to see. Let's add more lights. Bring the gamma down a bit. I think that's pretty cool. Yeah, so I want to write, but the plan was, still is, to write a game as much as possible from scratch. Oh, hang on, if I'm just talking, hang on, I'll get you think of this. Oh, exciting. The plan was, look, I wanted to make a game as most people want to do, but I kind of wanted to do as much of it as possible from scratch. So in my mind, that is doing, the rendering code from scratch, doing the window code from scratch, doing the input handling from scratch, just doing as much as possible, from scratch. Because one, I think there's a lot to be learned from doing that and kind of understanding really like the nitty gritty of how things work. And two, I think it's a lot of fun. And three, it's kind of interesting it's a good exercise in like system design and building up like abstractions and like using C++ to its fullest. So there's kind of a whole variety of reasons I wanted to do it and do it live as well. So that's kind of where we're at. The game will be. The game's currently. I'm undecided. I'm not committed yet to a specific game or what it'll be, but it will be. Be very simple. It's going to be a simple, like first-person kind of game. I think it's probably going to be like a puzzle game with like I don't know, some number of levels, and then we'll just build all those out live. My goal is my current goal. I'm not saying it won't change, but currently every line of code that is committed has been written live. So there'll be nothing in the game that I haven't done in front of everyone. So that means I don't work on it off stream. I do play around with things off stream. I try a few ideas or have a tweak around with things, but I either stash it or I revert it all. Everything in the game is done live. So So yeah, and that's kind of where we're at. So basically at the moment we've got model loading, we've got arbitrary number of lights, we have, as done today, HDR rendering, gamma correction, we've got, I guess that's kind of the main things. What's next is a proper asset pipeline. Just check what's my notes. Asset pipeline, frustum culling, physics, and then gameplay. And then we're just going to do a whole bunch of gameplay. Like we're just going to basically, there'll be several live streams where we just try out mechanics, code them up, see how easy they are to code, have a play around with it, and see where we kind of get to. So we're going to kind of feel that out from there. Yes, need to cull inside. Let me add that now. Cull inside faces. I think basically what my plan is, I'm not building an engine, and I've been very clear on that from the start. Like, this is not supposed to be generic code that you can kind of apply to everything. This is just like the bare minimum code to build the game that we end up building. So it won't be perfect. It might be a bit gross in some areas. You know, there might be a couple of hacks in there. It doesn't really matter because it's just what gets us to a game and doesn't have to be super generic. But also because of that, I only want to implement things that are explicitly needed for the game. So as we saw earlier, like, we only supported loading like RGB and RGBA textures. We don't support red only channel textures or anything like that because we don't need them. So I'm only adding stuff that we need, and then we'll see where we get to. I think this skybox looks a little bit blown out. Gonna switch back and have a quick look at that. Where do we do the skybox code? I think this also needs to be sRGB, right? Fix this up. Yeah, it's not really a lot. Yeah, I'm really pleased with how far we've gotten. And it's not a huge amount of code. That's better. That looks a bit better. There we go. I thought but you can see the difference when if you don't now specify sRGB format for the textures. OpenGL will apply the transform for you, so you effectively get double gamma corrected, which is why it's brighter. Is there still mouse button logs going on? Oh yeah. I think we'll do a bit of tidy up for the next. So the next stream I want to do the asset pipeline, and I don't think it'll take the full stream, so we'll definitely do some tidy up then. Let me just make a note of that. Remove. Let's do a tidy up logs. But it's stuff like, so a good example of something on my to-do list is anti-aliasing, but we will eventually need it, but we don't need it now, and it's not getting us any closer to a game, so that's something we can just add later on. Same as like SSAO. Like I'd like to do ambient occlusion because it's a fun thing to implement, but we don't need it. So I guess you could argue we didn't need HDR, but like I just wanted to do that because I needed to build up the frame buffer pipe, the render target, the render texture pipeline anyway. So strip functions from stack trace. So that will be when we do a release build, we'll make sure that all the logging kind of gets removed and a load of other stuff as well. So we'll have to but all the stuff that goes around building the game, I want to do live as well. So I want to do like making the release build and testing it, and that kind of thing. Packaging it up and shipping it up to itch.io or something like that, like or Steam. I kind of want to do as much of the process live as possible. Okay, well, I think it's pretty good place to end. Shame the lights are now darker, but then that is kind of by design. I guess we could fudge around with these a little bit. I think now what we can technically do is we can make the lights brighter. We can make them, I can't do it on this slider, but we can make the lights exceed 255. So what I might do is add an intensity slider to all these, which is like a multiplier. So it'll start off as 1, but if we want to make the light super intensive, we can multiply all these components by the intensity. As in, like, yeah, I guess the stack trace is a bit gross at the moment, so we could tidy that up. There is no shortage of things to do, and we'll definitely do them all live. Hang on, what am I doing? What's exciting is I've ordered a Stream Deck, and it's not arrived yet, so hopefully in the next stream I'll be able to just like button press and do all these fancy transitions, because you know, I'm a fully fledged streamer now, so you got to have a Stream Deck, otherwise are you even really streaming? That's kind of all I had for today. That took about as long as I thought it was going to take, so thank you very much for everyone coming along. I guess before everyone disappears, I'm hoping to stream on Wednesday, but I appreciate that is New Year's Day, so I don't know what my plans are yet, but keep an eye out on the YouTube channel, because I will post on the community board, because I'll post there. If not, then it will definitely be the following Sunday, but I'm going to try and get one in on Wednesday, and we'll start doing the asset pipeline. I hope everyone had a great Christmas. I hope everyone enjoyed the stream. Thank you much for coming along. Much appreciated. And I will catch you on the next one. Thanks very much.